One of the most well-known star nurseries in the cosmos, the Orion Nebula, may include a new kind of object that astronomers have discovered. What if I told you that the James Webb Telescope has discovered many structures that entirely violate our understanding of how space works, instead of just one or two things that shouldn't exist? Scientists are baffled by NASA's latest findings from the James Webb Space Telescope, which showed 6 huge galaxies that defy accepted scientific theories. We could have to revise textbooks on star formation, galaxy creation, and the nature of the universe itself in light of these discoveries. Let's explore these startling discoveries. Huge, old galaxies are number 1. Envision a large, seemingly routine area of space and then, bang! There are 6 blazing red specks of light that stand out against the black background of the cosmos. These 6 mysterious red spots were recently discovered by the James Webb Telescope, and they are not your typical space blips. With a staggering 13.3 billion years of age, these galaxies are among the largest and oldest ever discovered. These 6 spots show formation within a few hundred million years after the Big Bang because of how deeply crimson they were. The worst part is that this contradicts earlier scientific theories. Experts had thought that the universe's dark ages had been extended and that the formation of the first stars and galaxies had taken significantly longer. However, far sooner than expected, these old galaxies were already enormous and exploding with star formation. Not only is one of these dubbed universe-breaker galaxies massive, it has 10 times the Milky Way's volume and 1 trillion times the mass of our Sun. The astronomy world has been shocked by this discovery, which casts doubt on our theory of the universe's origin. Is it possible that the early cosmos wasn't as silent and unremarkable as we previously believed? It appears that the universe's dark ages might not have been as dark as we always thought. Novel discoveries in exoplanet molecules. Researchers have been searching for an exoplanet that could support life for a long time. Among the various possibilities, K2-18b stands out. What's the big deal about this far-off world? Recently, scientists have found water vapor in its atmosphere, which is an essential component of life as we know it. However, that is only the start. Carbon-containing compounds like as carbon dioxide and methane have also been detected by the James Webb Telescope on K2-18b. What does this signify? It raises the intriguing possibility that this planet has a water ocean beneath it and an atmosphere rich in hydrogen, almost the ideal conditions for life. If that wasn't exciting enough, researchers have also found dimethyl sulfide, a substance that is mostly made by Earth's living things. So, is this evidence of extraterrestrial life? Though it may be too soon to say for sure, there's something intriguing about the way the dots are connecting. The cosmic web's origins. Part 3. Ever pondered what the cosmos was like right after it was created? Astronomers have taken a picture of a cosmic web growing just 830 million years after the Big Bang using NASA's James Webb Telescope. They found 10 galaxies organized in a line in this image, giving the appearance of a string extending across space. This cosmic thread holds information about the universe's early years, much like discovering a childhood portrait of it. Here's where it gets even more amazing. Galaxies of that kind shouldn't even have existed at that time, based on what we currently know. Approximately 3 million light-years long, this galaxy string is held together by a super-bright quasar, which is essentially a galaxy with a massive black hole at its heart. This galactic line may develop into a massive galaxy cluster similar to the well-known Coma cluster in our cosmic neighborhood. According to scientific speculation, it resembles observing a cosmic nursery in action as galaxies that will eventually form the universe's building pieces being raised. Early supermassive black holes. Number 4. Most of us are aware that black holes expand through the consumption of nearby stars, gas, and dust. Far sooner than they should have been allowed to grow to such a colossal size, supermassive black holes have now been seen in motion during the early cosmos, according to the James Webb Telescope. Surprisingly, the telescope managed to photograph the farthest black hole ever detected in X-rays, situated in the UHC-1 galaxy. The astounding distance of 13.2 billion light-years between UHC-1 and Earth indicates that we are viewing this black hole as it was 470 million years after the Big Bang. Its mass, between 10 million and 100 million times that of our Sun, makes this even more amazing. To put this into perspective, The mass of this black hole is equivalent to the total mass of all the stars in its host galaxy. This begs some important issues about how black holes might form in the early cosmos and grow so quickly. The Horsehead Nebula is number 5. The Horsehead Nebula, also known as Barnard 33, is located roughly 1,300 light-years from Earth. Astronomers love it for its distinctive shape and vivid brightness. For the first time, astronomers can now see into the small-scale architecture of the lighted border of the nebula thanks to the sensors on board the James Webb Telescope. This nebula is illuminated by a nearby bright star and produced from a collapsing interstellar cloud. Over time, the majority of the surrounding gas clouds have scattered, but the pillar-shaped nebula remains intact due to its dense material composition. But before it begins to dissipate, astronomers believe the Horsehead Nebula has roughly 5 million years left. Because of Webb's observations, scientists have also been able to follow the delicate and complicated patterns that are formed when dust particles evaporate under UV radiation and are carried away from the cloud. The dust remaining after a supernova. The key to understanding the formation of planets and life may be found in Cassiopeia A, the leftovers of a huge star explosion located approximately 11,000 light-years away. The warm dust left behind by this explosion, which occurred about 3,140 years ago, is of great interest to astronomers as it is essential to the formation of planets. It is believed that the majority of this dust comes from heavy elements released by supernovae. Sulfur, oxygen, argon, and neon are among the components that make up the minute pieces of cosmic debris that can now be observed thanks to the James Webb Telescope. These pieces combine to form a breathtaking cosmic tapestry as they shine in lovely orange and pink tones. The light echoes seen here, when the surrounding space matter absorbs and re-emits the initial supernova light as infrared light, are even more fascinating. Scientists can now investigate the complex ways that stars affect the universe's cycle of life and death thanks to this discovery. Second, a region in the Serpens Nebula that forms stars stretching over an enormous region of roughly 16 trillion by 11 trillion miles. The Serpens Nebula is located further away and acts as a stellar nursery where nascent stars are taking their first breaths. Astronomers have never before had such a clear picture of this area thanks to the James Webb Space Telescope, which has seen many synchronized protostellar outflows, or gas jets that are released by young stars when they interact with the surrounding gas and dust. What's odd about it? It is the first time that such an alignment of discharges has been seen in one direction. This fresh information provides a rare window into the formation and dynamics of stars. The planet-forming disk known as the bat shadow, which looks to flap like a bat's wings, is another amazing feature that the telescope revealed, adding to the nebula's enigmatic appeal. Hidden aspects at the center of the Milky Way. Additionally, the James Webb Space Telescope is assisting us in better understanding our own galaxy. Its near-infrared camera just took the most detailed picture of the Sagittarius C area, which is around 300 light-years away from the center supermassive black hole of the Milky Way. Astronomers detected about 500,000 stars in this picture, but several needle-like features in ionized hydrogen have been seen by the telescope that extend much beyond prior estimates and defy all known patterns. The telescope also discovered a cluster of protostars, which are young stars that are still growing and accumulating mass, adding to the intrigue. This finding shows us that even the well-known Milky Way galaxy still has mysteries to reveal by giving us a glimpse into the powerful processes occurring at its core. The cosmic narrative we previously believed to be true is being altered by these findings, which were made possible by the James Webb Space Telescope. They are pushing scientists to reconsider the mechanisms underlying star birth, galaxy formation, and even the possibility of extraterrestrial life. And this is only the start. What more could be discovered in the future by the James Webb Telescope? These discoveries serve as a stark reminder that there are still many mysteries in the cosmos. Please feel free to comment, and don't forget to subscribe for more incredible cosmic discoveries.